So part 2 of today's lesson, we're completing the square to solve this quadratic. So this came from part 1, just ran out of time on that, so here it is. So it talks about the height h in feet of a rocket launched off the roof is given by this equation. Notice that 32 feet, this is the height of the roof, so we know some information. This is our initial height right here, this 32 feet, initial height. And then also this number right here, this is the initial velocity. And this 16 comes from the half, and then it's actually the opposite of half, acceleration due to gravity. So that's where the formula comes from, and you'll see it in your physics class later on, but oftentimes we use it in the algebra class just to let you know where these formulas are used or why we actually have to learn them. So we want to find out, when will it return to the ground? Return to the ground tells us right away that we're going to take that h and we're going to set it equal to 0. So we're going to put 0 in place of that h right there, and then we're going to try to solve this by completing the square. So if we're solving by completing the square, this is the first step. We're going to move this 32 to the other side. After I write it out, I'm going to just subtract that from both sides. And then from there, I'm going to end up having this. Negative 32 equals a negative 16t squared plus 288. Now, you could leave the 16 in there. You'd have to get rid of the negative sign, though. But I'm going to go ahead and just get rid of the 16 altogether. That's the first thing I do, is always divide by the a term. And you'll see that later on when we come up with a new formula to solve a quadratic called the quadratic formula. But for right now, we're going to go ahead and continue here. We divided, and we have 2 equals, and this makes a t squared, and it's a minus now. And 288, 16 goes into 288 18 times. 18t, I forgot to write that t right here. So let's go ahead and squeeze it in there. And so from this point, we're going to go ahead and take half the b term, because we need to complete the square now. So take half this number, and that makes negative 9. So right away, I know what the factored form of this is going to be. I know it's going to be a t minus 9, because 9 plus 9 makes 18. Negative 9 plus negative 9 makes 18. But I need to figure out what it is I need to add to this to make this a perfect square. We'll just take that negative 9 and square it. And that makes 81. And so that's what you get when you multiply negative 9 times negative 9, but you got to add it to both sides. And so this all equals 83. So we go ahead and take the square root of both sides, and then we'll come up with our values of t. So we have t minus 9 equals plus or minus the square root of 83. Well, 83 is not a perfect square, but we could approximate it. So just plugging it into the calculator, and actually just thinking about it, I know 81 is going to end up being 9, so I'm going to approximate this to about, this is going to be pretty close to, plus or minus 9.1, let's say. And when I go ahead and punch it in the calculator, this is what I ended up getting from the calculator. It gave me an approximate again, 9.110433, and then it kind of went on. But again, that's just an approximate. The calculator will eventually round the number itself. And so that's what we end up getting. That's pretty close to what we said. And so just thinking about it, and knowing that 83 is close to the square root of 81, so it makes sense to us. And so we go ahead and write t minus 9, and then we do some opposite operations to solve. So we end up having to add 9 to both sides. We come up with these different answers. So our first one, 9.1 plus 9 gives me 18.1. That's one of them, and then I have to do the negative 9.1 plus 9, and that gives me negative 0 1/10. So which one do we go with? Well, the reason why we have 2 answers is from the graph. Here you started 32 feet up, and it goes up, and then it comes back down. And there is the 18.1. That's the one we want. But why do we have this other answer? Well, it's because these graphs are symmetrical. See, they continue off in this direction, they continue off in this direction, and it would end up actually crossing the x-axis again here at negative 0.1. And since that is a negative number, we're not going to use it. It doesn't follow what the actual time is that we're using. See, we are looking at what's really happening. You see here it's launching, time is increasing, and it eventually hits the ground 18 1/10 of a second later. And so that's why we go with 18 1/10 of a second. So there it is. So problems from tonight's homework. Good luck!